Hello everyone. Today I want to talk a little bit about chromosomal mutations. And as I touched on class for you already, and so today I just want to do a quick guide video to show you again some animation, some short animation for you to understand more about the chromosomal mutation. And so as you know, we have two main groups. That's a group who affect on the number of chromosome, and the other one will affect on structure of chromosome. And for the number of chromosome, you have two main groups. The first one is polyploidy, and the other one is aneuploidy. And so you already know the differences between two main these group already, right? And so for polyploidies here, as you see, that's normally we have a cells with haploidy, with gametous cells. And for the other cell in our human body, we'll have diploidy. And so that means here they have the abnormal number chromosome here. You see on the screen here, they are triploidy. That means for is you see three chromosomes go together like this. For normally we will have two only, exception of gametous cells. They will have only one. And here there is a kind of polyploidy here. And for a normal gametous cells, after meiosis, you see they will have a cell with haploidy like this. Yeah. And so if they have fertilization, they will have a diploidy. They will have two chromosomes go together, homologous, as you know. And here this is the way they have create triploidy or tetraploidy. And as you see here, most of triploidies here, they will have 66%. They have compiled from two sperms, go to one egg here, or the other one they have abnormal egg or abnormal sperm. They have diploidy. And so when the other one with haploidy go together, they will have formation of triploidy. And so most of triploidy here, they will get two sperm have invade into one egg. And so this one accounts for 66%. And so how about aneuploidy? And as you see, I told you we have totally 5 types of aneuploidy. And so for normal one, we have like this diploidy here. And so for we have 1, 2, 3, 5, 1, 2, 3, 4, 5. And so this is for normal we have 4 pairs of chromosomes here. And the first case here, they are lacking up both of number chromosome, a pair of chromosome here. And so you call this one is nullisomy. And so this the second case here, you see they are lacking up just one chromosome here. And so you call this case monosomy. And for this one, for first case here, you also see they are lacking chromosome, but they are lacking up not only one, they are lacking of both on chromosome 3 and on chromosome 4. And so that means they also a case of monosomy. They are still lacking up too, but they are also called monosomy. And so for the fourth case here, you will see they have one more chromosome, one extra chromosome here. And so this case represent for trisomy. And as you know, we also talk a lot about some patient in human, they have trisomy. For example, Down syndrome, Pratt-Tau, or Edwards syndrome. And so for this case, they have two more extra chromosomes here. For example, here they have only in chromosome 4, they have a pair of chromosomes. And for the last case here, you see they have one more pair, that's on chromosome 3 and on chromosome 4. And this patient you can call tetrasomy. Yeah, tetrasomy. And so one more case, if you still remember, beside nolisomy, monosomy, trisomy, tetrasomy, you have one case, that's mosaicism. That means that person will have not only 46 chromosome in their human cells, but also they still have some kinds of other karyotype. For example, they have maybe 47 or 45. It depends on the syndrome that the patient have. And so that means for a aneuploidy, you have 5 types of them. Remember that. 5 types of aneuploidy. They are nullisomy, monosomy, trisomy, tetrasomy, and mosaicism. Okay, remember that. And so for on about the abnormal of number of chromosome, and now we move to the structural of chromosome. And so here, before talking about the structural, I want to mention about the sap of chromosome. Here, as you see, we have 2 types of chromosomes as you see in our cell cycle. And so from S phase in cell cycle, the chromosome have duplicated, and so they keep this sap from S phase to metaphase. And so for all the phase in cell cycle, you see they have chromosome with this sap. That means we call that unduplicated chromosome, and here duplicated chromosome. And so for duplicated chromosome, you will have chromatid. For this one, you don't have chromatid. Remember that. And so this is, they will consist the chromatid with this chromosome. And so we have 2 form of chromosome. The first one unduplicated, and the other one is duplicated. And so for structural chromosomal abnormalities here, you see we have 2 main groups. The first one affect on chromatid type. And so for the other group, they will affect on chromosome. And so what does that mean? That means this will affect from S phase until metaphase, where they have the duplicated chromosome. You will call chromatid type. And so for on the cell cycle, which can affect not only on unduplicated and duplicated chromosome, we will call this group affect on chromosome. And so for chromatid type here, they just mention 3 kinds of chromatid types. I'm looking up one more E at the end here, chromatid type. And so they have mentioned here with some effect on just one chromatid only. This one just effect on one chromatid. And so for example, the first one here, we will call the name here isogap. That means for duplicated chromosome, they have a segment of chromosome of chromatid. They don't stain the color when they have stained chromosome, and so they just have one segment on one chromatid. They are lacking up the color, and so they will call isogap. And so for the other one here, they will call isobreak. That means they also have a short segment on chromatid. They are break, and so that's a break segment. They may be lie far away from the chromosome here, but they just have a break on chromatid only, and so that's chromosome we are lacking up a short segment of chromatid, and so they will call isobreak. And so for this one, this is the chromosome is changing. I don't know why. Maybe they have I have mutation here. The last one, that's they will call it changing. That means when they have break from other chromatids on a loss of chromosome, and so they chain together and they have a new form, and so you will call this one chromatid change. And so for chromatid type, remember that just affect on chromatids only. And so this is the first group. For the other groups, you call chromosome type. That means will affect on both duplicated chromosome or unduplicated chromosome. And so totally we have 8 types. And so what are they? For isogap here, when they happen on chromosome type, that means they have not only effect on one chromatid, they also happen on both chromatids together. And so you call the first one double isogap. It is a little bit similar with chromatid type with isogap, but this one happened on both chromatids together at the same position, but both on both chromatids. And this one is the same. They have double isobreak. That means happen on both. And for other ones, you have learned already that they are deletion, duplication, inversion, and translocation. And so I will focus on 4 types here for you to see through the animation, for you to understand about the principle. And so we have 2 other kinds. They will call 2 centromere chromosome. That means for normal we have just 1 centromere, but this abnormal, after they have it chain with the other chromosome, maybe they will form a new chromosome with 2 centromere. And one more, they will call this one isochromosome. That means they will have abnormal when they have separate chromosome go to in anaphase of mitosis. As you see, they have segregation of 2 chromosomes to go to opposite side in anaphase. But here, for example, for normal way, they will segregation chromosome from up to bottom like this. And for isochromosome here, they don't have the normal way like this. They will have divide like equatorial like this from here to here. not from here to here. And so they form two new chromosomes, and so that chromosome we will call isochromosome. And so for four main kinds about the deletion, duplication, inversion, and translocation here. And so this is a sample for you to see the chromosome with the centromere. They have the symbol like this. For deletion here you see they have delete B segment here, and duplication they have duplication B. And how can happen I will show you later. For inversion here you see you look like the length of chromosome is the same, but you see they have changed the position of, or you see especially the nucleotide sequence they change, and so that affect on structure of chromosome. And so here for translocation they have two other different chromosomes together, and so they have translocation happen. And so how many kinds of translocation, and so as I show you already. And here now we observe again on source animation here the first one here you see we will call deletion. And so after mutation the new chromosome shorter than before, they have just 6 segments of chromosome, not only 7 like the normal. And so this deletion just happened on the short arm of chromosome. And so one thing special I also mentioned already that it will have ring chromosome. And so if you see ring chromosome, you should think about the deletion on both arms of chromosome. As you see here, the segment width doesn't have centromere, they will disappear at a normal or natural rate, and for the other one they will run down and form a ring chromosome, as you see. And so here the inversion, and so they will change the structure of chromosome. As you see, they look like normal, but actually they are not. They have something changed on this sequence. And so for this case, you also know that this is reciprocal translocation. That means they have it changed on together. One will get assessment, the other one also get. And so this is called reciprocal translocation. And so this is specific we have learned, and so you will call this one is centric fusion translocation, and this just happened in our human chromosome at group D and group G, as I told you. And so when they have centric fusion translocation, we will form just only one new chromosome only. For normal we have 2, but after centric fusion we just got 1 chromosome. And so this is the last case of translocation, and so we will call this one non-reciprocal translocation. And so it's different with the first one with reciprocal translocation. And you see here the acrocentric chromosome here, they got the segment number 5, and for the chromosome bigger with 7 segments, they didn't receive, they didn't get anything. And so we'll call this non-reciprocal translocation. A little bit different And you see on the screen now, this is one of the duplication. And so this happened a little bit different with the, the previous one here. For this one, they have two non-homologous chromosomes. And here you see they have two homologous chromosomes go together. And so after they have exchanged one segment of chromosome the same with the other one, and so we will call this one a duplication. Yeah, that's all main thing I want to share through these videos. I hope you can understand well the abnormal of chromosome. Thank you for watching. Bye bye.